All right, good morning, everybody. Welcome to today's webinar. My name is Riley Pronto, and I'm the Director of Product Marketing here at Edge Delta. And I'm joined today by Zach Queering. Zach, do you want to introduce yourself?
Sounds good. My name is Zach Queering. I'm the Director of Solutions Architecture here at Edge Delta. So working with our existing customer base as well as kind of new customers with all the different use cases of Edge Delta.
Awesome, thanks, Zach. So today's topic is how to detect every anomaly and determine the root cause in minutes. This is going to be a live demo where we show you the inside the Edge Delta platform firsthand. And we're going to focus specifically on our automated observability feature set. But before I hand it off to Zach to do this live demo, I wanted to briefly touch on the problem we're solving as a company. So over the past several years, we've seen architectures become increasingly distributed. And as a result, we've seen data volumes explode. Yet the tools we use to analyze this data has remained static. So vendors continue to use a model in which customers must ingest and index complete raw data sets in order to ask questions upon that data and derive any value. When we talk to customers, we see three key shortcomings with this approach. So the first one is they have poor visibility into their apps and services. So customers will have to make decisions upfront about which data sets they need to centralize, ingest, and index. Sometimes this means log sampling, filtering out specific data sets. In other scenarios, maybe they have to shut off logging for specific periods of time. Or maybe they move data into a lower tier of storage where they can't ask questions upon that data in real time. The second challenge we see is manual and reactive processes. So in order to derive any value from this data, customers must build logic within their monitoring platforms. And on top of that, not only does this add a ton of time to an engineer's day, but the questions they can ask, they have to be aware of up front. And so they're not really looking for unknown unknowns and maybe taking a more proactive approach to observability. And then the last issue we see is related to performance. So as data volumes scale, we see query performance degrade, and in more extreme scenarios, a self-hosted solution might slow to a halt or in extreme scenarios fail. So how is Edge Delta solving this problem? So Edge Delta analyzes 100% of observability data as close to the source as possible, typically directly within a customer's compute environment. As you can see in this diagram, so Edge Delta is deployed via software agents, again, within a customer's compute environment. And at the agent level, we use a combination of distributed stream processing and federated machine learning to automatically analyze all data as it's created. The outputs of that analysis, so insights, statistics, aggregates, that's all streamed to your observability platform, and that's what's powering your dashboards. Meanwhile, 100% of the raw data that we capture, we route to a low-cost storage mechanism of your choice. And then lastly, the alerts that we generate happen at the agent level, so much closer to where the data is created than is possible with an observability platform. So we're seeing much faster insights, much faster alerts. By taking this approach, we're seeing three key benefits with customers. So the first benefit is that they are gaining 100% visibility into their mission critical systems. So no longer do customers have to decide upfront which data they'd like to centralize and which data they'd like to move to a different storage mechanism. They can analyze 100% of that data. So they're getting better analytics in their observability platforms and overall better visibility. Detect and resolve issues without manual toil. So at Edge Delta, we like to say we automate observability. And again, that's the focus of today's webinar. And what do we mean by that? So again, at the agent level, we are automatically analyzing 100% of the data. So the customer is not required to manually configure any logic within the platform. There's no regex or manual queries or anything like that. These insights are generated automatically. In terms of anomalies, we're able to detect every anomaly that occurs within these data sets. So they're taking a much more proactive approach. And then when we do detect an anomaly, we preserve all context of that event so a customer can resolve that issue in minutes. Then this last benefit, process every event in real time at any scale. This is related to performance. So customers are able to, by stream processing each data point as it's created versus centralizing all their raw data and then batch processing it, they're able to alleviate any performance bottlenecks and generate faster insights and faster alerts. So with that, that's my overview of Edge Delta. I'm going to hand it off to Zach, and he's going to show you the platform itself. So Zach, I'll stop sharing here and go ahead and take it away.
Sounds good. Let me go ahead and share out my screen here. Should be able to see that coming through. Perfect. So as Riley mentioned, at a high level, we refer to Edge Delta as an automated observability pipeline, a platform that acts as a stream processing layer between raw observability data, such as application logs, and what we refer to as streaming destinations, platforms such as typically existing observability platforms like Splunk, Elastic, Datadog, Sumo Logic, and many others. We're taking these raw data feeds as inputs and performing automated real-time analysis against the streams as the data is being generated to do things like generate baselines and statistics, detect issues, provide insights, and intelligently route and optimize the raw data as it's flowing to the various streaming destinations, as well as providing the option to route all of the underlying raw data to what we call archive destinations, platforms like S3, Azure Blob Storage, and many others, where at any point you can perform what's called a rehydration and kind of extract data from those different systems at different times. So there's kind of a lot of different use cases that our customers use Edge Delta for, everything from this concept of data optimization to observability pipelines. But really the core of what we'll be focused on today is this concept of automated observability, which is a unique approach that's essentially only possible by performing these stream processing analytics against the raw data at scale to be able to do things like automatically uncover various anomalies, types of incidents, different issues, and both detect these proactively without requiring you to set up any upfront alerting mechanisms or logic or conditions or those types of things, but also assist with and enhance the troubleshooting, debugging, root cause analysis process. So I'll kind of cover the basics of how we do that. I think one additional core piece that's worth mentioning is, the core of the technology is really this kind of processing layer between the raw data and the different systems we integrate with. We also have our own Edge Delta front end to visualize the different insights and the things that we're uncovering in the data. But we also send all the same analytics to downstream systems and kind of all the platforms they integrate with. So as part of this walkthrough, I'll show examples both in the Edge Delta UI, as well as an example streaming destination with some of the things that we provide out of the box as part of a deployment of the pipeline. So kind of getting into that here, I'll go ahead and just kind of walk through, if we were to say, hey, we want to go ahead and start with deploying Edge Delta in one of our environments. Let's take, for the focus of this demo, we'll use Kubernetes as an example. So if we said, hey, let's go ahead and, let's roll out Edge Delta straight to our production instances. If we wanted to, we could also set up the various types of integration. So there's streaming destinations for real-time analytics. There's trigger destinations for alerting or receiving the kind of the findings from the platform. And then also those archive destinations that we talked about for routing, for storage and retention and different things there. From there, all we would need to do are essentially run these 3 or 4 commands. That's going to do everything from deploy the Edge Delta agent, perform auto discovery, discover all the different components, to start analyzing and begin monitoring, and start to kind of kick off the automated baseline and data analytics process. So we can go ahead and kind of walk through what we're seeing there. That kind of takes us to the state that we're looking at here, where you can see things like where are we collecting data from, where is it being routed to, and some different concepts around kind of the high level of the Edge Delta pipeline there. Drilling into one of these environments here, one of the first things that starts happening within seconds of raw data flowing through the pipeline, this is all a completely automated process. It doesn't require any configuration or setup as part of kind of onboarding, is this concept of automated pattern analysis of the log data. And so essentially what this does is, if we look at this chart here, let's say on average for this particular environment, we're seeing roughly, 40,000 raw log records, in this case per minute. Across those 40,000 raw logs, It's really just 30 patterns of these logs that have been automatically identified. So what we call a pattern is really kind of a summarized version of the log entry that we're seeing. So in this case, we can see this info log, for example, makes up 590,000 events within this window, or 17% of our total. We can see this info log, is essentially the identical message being repeated over and over and over again, 580,000 records, or 16.8% of our total traffic. And then there's going to be different patterns of all shapes and sizes, happening at various frequencies as we're flowing through. So agents are deployed, raw data starts getting processed. These patterns automatically get created on at the same time. Kind of the analytics about these can be streamed to downstream systems for visualization, for analysis, and things like that. But at the same time, the platform then also starts to baseline a number of the characteristics of these patterns across a number of different dimensions. So starting with some of the different characteristics, these are going to be things like, how are these patterns changing over time? Are they increasing? Are they decreasing? Maybe they're, gone. They used to exist, but now they're not there. Maybe they're new and the pipeline's never seen them before. There's also this concept of the edge delta anomaly score. We'll go in, excuse me, we'll go into this a little bit more detail, but essentially that's something that's used as part of this baseline process to compare, hey, how anomalous is the data we just saw to what we've seen historically? And then also applying this concept of sentiment analysis, automated sentiment analysis to these patterns to essentially classify them as being negative, neutral, or positive. So from a kind of an operations or observability monitoring perspective, negative sentiment, it's going to be looking for things like, are these errors, exceptions, stack traces, timeouts, seg faults, disconnects, 400s, 500s, all these different things. And then, positive sentiment's going to be more things like, successes, 200 okay, and everything you might look for there. So those are some of the different kind of characteristics of the data that it's looking at. And then also kind of baselining these different characteristics automatically across a number of different dimensions. So when we talk about dimensions, we can show an example here of, this environment happens to be a Kubernetes cluster. So it's automatically going to do auto discovery to figure out, what are the various namespaces, controllers, containers, and it's creating these baselines automatically, independently across all these different dimensions of these systems. So it can start to look for things like, hey, in this particular system, let's say typically it's normal to see about, 95% positive sentiment traffic and 5% negative sentiment. And that's the general trend over time. But then all of a sudden, some system has a significant increase in negative sentiment traffic, and the pattern's starting to change, and it's something that hasn't been seen before. It's, it's not cyclical, it's kind of new behavior within the pipeline. That would get flagged as a finding, which is something that you could have triggered as an alert or a notification. So a quick example of that is one that recently fired in this environment. In this case, we have it integrated into Slack, where it's basically telling us, hey, we saw this increase in negative sentiment traffic in this particular environment. In this case, it's calling out the specific Kubernetes namespace that this was identified in, and basically kind of providing a high-level overview of what happened around that time. And then from here, we have different options. So I'll go ahead and kind of pull up both of these, but I'll start with Edge Delta, kind of our UI, to kind of explain a little bit about what's happening here. So in this case, it pinpointed, hey, within this time range for these different components, typically we were seeing about, 3,800 negative events per minute. And we can kind of see the baseline that was expected there. But then right around 704, 705, all of these other negative patterns started to spawn, which is something that it wasn't seen in the past. And we can also see this just by looking at some of the kind of the statistics about these. So a lot of them are new, a lot of them are negative sentiment types of events. So it's kind of one, identify that there's some type of issue taking place without us having to set up any type of alerting logic to look for anything specific, or a threshold around, hey, if it goes above 5,000 per minute or 10,000 per minute, alert me, which those values could change throughout the day of, the day of the week or the time of day or whatever that is. But then at the same time, now that we know this is taking place from a more of a troubleshooting investigation standpoint, if we were just simply looking at all of the raw log data, we would potentially be looking at a massive set or timeline of raw logs. We'd also be, playing a little bit of kind of whack-a-mole in terms of which log should I search for, what should I filter out, what time range is kind of the one that I should be looking at. So this kind of summarized analysis of the data allows it to, help investigate these things much faster. So for example, one of the things we can do is say, hey, let's only look at the volatile patterns. And volatile is the ones that have a significant deviation from normal trends during this window. And that's showing us, in this case, most of those are all the new patterns that we're seeing. And, at the bottom of the list here, we can see a couple that are only happening once or twice that would be very, very difficult to find if we were looking through a massive set of data. So we can see in this case, it looks like somebody accessed the CLI over root, went in, potentially deleted a Kubernetes access key. And, that was right around the time 7:05 that we started to see some of this behavior spawn. So this is just kind of an example of some of the different things there. I know I'm covering a lot, and so just want to take a pause there and see if there's any questions on any of the things we've walked through so far. So sounds good. So to kind of continue on a little bit there, another concept that's very common with in terms of monitoring or analyzing, this use case specifically kind of log data, is within individual events. It's common to see things like I'll pick one as an example here. This log, for example, has things like status code distributions. Is it 200s, 400s, 500s? Things like millisecond response times. How are these trending over time? Or which API is being called, or the user, the trace ID. So another component that's very core to Edge Delta is as these raw events are flowing through the pipeline, we're able to extract these kind of statistics and insights from the data, analyze and inspect every single log event, and send the analytics to any downstream system. It could be a time series backend, it could be a log-based backend, or any other system. But then just by virtue of us kind of doing that analysis and sending these different data sets downstream, we also baseline the characteristics of these types of statistics and insights and trends across these data sets to identify different patterns and see if there's different things being detected around that time. So to kind of show an example of that, in this case, this, I'll kind of pull up an example. This is showing, in this case, Datadog is a downstream destination. All of these charts that we're seeing here started as raw logs flowing through the Edge Delta pipeline. And then we extracted these different statistics, fed them to the downstream system. So in this case, for this environment, we're monitoring things like the 200 rate, the API response time by different services, the error rate by different services, and things like that. But then what we also do as part of just creating these statistics is create what's called the Edge Delta anomaly score. We kind of touched on that a little bit before, but this is essentially, it's always a value between 0 and 100 of how confident are we that the data we just saw looks anomalous compared to the data we've seen in the past. So 0 to 100, 100% confident is, hey, we're very confident. 0 is, I don't know, it looks pretty similar to what we're typically seeing. So for example, here in this system, the 200 rate is staying pretty consistent. So the anomaly score is, fluctuating just briefly, but nothing we'd really be concerned about. Now, around that same window, 7:05, where we saw that pattern insight finding for one of our clusters, one of our namespaces, the API, both the API response time and the error rate, those values started to spike as well. And that was reflected in the Edge Delta anomaly score. So in this case, it jumped up to close to 100% for these different environments. When these anomaly scores jump high, that's where we can do, there's a lot of different things we can do. One of those are, generate findings or use those as kind of additional confidence about other things we're seeing in the system. But then it can also trigger this process of what we call dynamic raw data routing, which is essentially saying for certain data sets, this is typically something that's used for like, very high volume, large data sets that we might be analyzing. For certain data sets, if, hey, everything's looking happy and healthy and steady state within these systems, we're always going to get the analytics so we can kind of monitor what's happening, but in a much, much like very, very lightweight footprint into our downstream systems. But then if something interesting is seen, like some of our statistics are changing and things are starting to look anomalous within the system, that can tell the pipeline, hey, let's go ahead and actually dynamically, temporarily capture all of the raw data, both before and after this window, and send that to the downstream system so that we can correlate what's happening, because that's probably a window that we're going to want to go, look through these different events and understand what's happening. So that's kind of an example of what we're seeing here. At this window where these anomaly scores spiked high, that was telling the pipeline, hey, let's send all the raw data so that we, all of our various queries and different things that we might want to look for, we can kind of sift through during that time. And then kind of hopping back into Edge Delta, that same concept is something that we kind of bubble up in this concept of kind of insights about our pipeline. So what this is showing us here is kind of on the left, these are all the different things that it's monitoring from the underlying raw data. So things like the error rate, the response time, the error log levels, the fails, the 400s, 500s, and each of these diamonds represents a point in time that one of these was flagged as anomalous. In this case, almost all of these were flagged as anomalous within a very short time window of each other. But we could drill into any one of these and we can see things like, hey, which specific component did this happen in? In this case, it's that namespace that was flagged for our finding. We can see things like what are some of the, in this case, the anomalous millisecond response times that contributed to kind of this issue here. And then kind of comparing these charts again, the stat trends, this is just the raw statistic derived from analyzing every event. And, around this window, when it went from 150 milliseconds up to 1200, that was reflected in the anomaly score, which kind of kicked off this process. So one, doing this kind of baselining and looking these different statistics for us. But then on top of that, we might not want to know every time if, let's say, one of these individual things is anomalous, like, the error level changes for a given system. We might want to know about it, but we might not want to, wake on call up at 3 a.m. to go investigate that. So what we do to kind of add or enhance this process is this concept of correlated findings. And what that does is actually look for cases of time where it's not just maybe one or two things that are looking like they're anomalous, but a number of different things all happening within the same time, and then inspecting which components, which systems that these happen in, overlaying that with kind of that, that example I showed with the pattern findings and things like that, to be able to really help pinpoint and have kind of an extra layer of confidence that, hey, this is actionable, something's definitely changing, and these are the components to go take a look at during that time. So I know I'm covering a lot there as well, but want to take a pause and see if there's any questions on any of those pieces.
So two questions real quick, Zach. So the first one we got is earlier you were showing findings and it kind of pinpointed the system that was affected. How granular are those insights? Like, let's say I'm running a Kubernetes cluster with many services and many namespaces. Is it going to just show me the cluster? Like, what level of granularity am I going to get there?
Yeah, so it's kind of up to, like, there's different options. Like in this case, this particular finding is basically saying, hey, we want to know what's happening down to the pod level, but we can set different like roll up granularities. So if we want to say, hey, let's, for example, if it's a Kubernetes cluster, let's just baseline each namespace independently, or maybe we have kind of a core namespace within our cluster that has most of our microservices broken out as, deployments or controllers or whatever those are. So let's kind of monitor this namespace, but actually baseline each controller or, whatever it is. So it's very flexible, but by default, it's going to kind of do a combination of both, of look at things at down to the pod level, but also look at things at a much kind of higher level within the different components there.
And how hard is that for a customer to set up?
It's very straightforward. So for example, a lot of these pieces are set up by default. So just by virtue of creating an account, a lot of what we walk through is kind of included there. But for example, here, if we go back to, I'm going to remove some of these filters and just say, hey, let's look at in this case, we're just at the Kubernetes cluster level for this environment. So we can see all the namespaces, controllers, and things like that. If we want to say, hey, let's create a custom Skyline alert, for example, where we look at each namespace independently and save this, then that's basically telling the system for this Kubernetes cluster, look at each namespace independently. And if one of those has one of these findings, it'll pinpoint which namespace that's happening. We could also say something like, a lot of times what we see is there might be, like a handful of namespaces in an environment, but one of them is the core kind of production namespace that's running all the microservices. So we might say like, hey, let's isolate that namespace in particular. And then when we create this, let's have it grouped by the controllers, for example. So now it's looking at each of those independently. Or we could say, something that's kind of in the process of being deployed right now is actually dynamically kind of doing a lot of this for us. So it'll start by looking at the higher level components, like this is all a Kubernetes example, but say, hey, let's look at all the namespaces independently. We've identified that this one is having some anomalous activity. Now for that namespace, let's look at all of the controllers, all of the containers, all of the pods, et cetera, and pinpoint like which ones are contributing so that it's, very clear what's happening. But what I just walked through is, just a few clicks and saving that. We didn't really need to write any query. We're just kind of telling it if we want to be a little more specific about what things to look for.
That's awesome. That's great. Second question here is you touched on the raw data capture. How long is that data? So let's say there's an anomalous event. How long before and after is that going to capture raw logs for?
So it's all configurable. There's basically 3 different settings. It can either be an event-based buffer. So events meaning, like, let's say it's set to 10,000. It'll have 5,000 raw logs before and after. It can be a time-based buffer. So let's say 10 minutes. So 5 minutes before, 5 minutes after. Or a size. So size would be like, 50 megs. 25 before and after. So it's there's different options there. By default, I believe it's event-based, kind of based on that.
That's great. Awesome. Go ahead.
Yeah. That's like, in terms of the example from today, I think that really kind of covers some of the core use cases that I wanted to kind of review in specifics to the concept of automated observability. But happy to answer, any other maybe high level questions about the pipeline or other use cases or, anything that might be interesting there.
Yeah, no, we got one question in just now. How do we ship data to Edge Delta for analysis?
Yeah, so there's a lot of different kind of architectures that we support. Something that's kind of unique about the pipeline is typically most of the kind of the initial analysis or processing of data is happening at the point of data creation. So in the example for Kubernetes, typically we're deploying Edge Delta as a daemon set. You can kind of think of our agent as similar to something like a Fluentd, FileBeat, Vector, Splunk Universal Forwarder, like all those kind of agents in the space. The difference being not only are we kind of collecting the raw data at the source, but also performing these analytics, pattern creation, data routing, dynamic raw data routing, like all those different things that we've talked about so far. And then from a kind of analytics perspective, it's it's essentially optional if we want to have these kind of views that we're showing in Edge Delta. For the various streaming destinations we typically integrate with, we have, out of the box, like you'll notice, this dashboard that we're seeing here with these charts and statistics, it's going to look very similar to what we're seeing in these downstream systems. So there's actually no requirement to send the underlying raw data to the Edge Delta kind of backend. But from a data collection perspective, there's the Edge Delta agent. We also have concepts of hosted agents, which are basically endpoints we can expose to kind of stream data to the Edge Delta backend for additional analysis. For typically that's use cases of things like serverless functions, CDN logs, platforms where there's not an obvious place to deploy an agent. But we can also collect from things like Kafka pipelines or forking data off a Kafka topic. So there's a lot of different architectures depending on kind of the existing infrastructure, existing pipelines, and what makes the most sense to kind of wedge Edge Delta into the pipeline.
Awesome. And then with the agent, what level of fleet management capabilities do we provide?
Yeah, a lot of different capabilities in that regard. So, showing kind of this view here, this pipeline status, this is showing us a few high level statistics of kind of the general pipeline. But then from there, we can see things like where do we have agents deployed? What are the, how much throughput are we seeing? What version are they running? We can also check the individual health of any of these components. So from a health perspective, that's things like, are we streaming data correctly to all of our various streaming or archive destinations? Is it all successful? So we can monitor all of that underlying kind of behavior of the pipeline. There's a ton of different things that we can do from a fleet management perspective, checking the deployment if we make updates or things to the agents. And then at the same time, all of the underlying health data about the pipeline. So things like, are we streaming to the right destinations? Is the data making it to where it's supposed to successfully? Are the agents up and running and healthy? And there's any CPU memory statistics, stuff like that. We can also feed that data to the downstream observability platforms where we have dashboards to kind of view the health, view the fleet management, which is something that's kind of unique to Edge Delta compared to other maybe open source agents that are commonly used, where getting that kind of granular visibility into what's happening with the data. Is it being collected correctly? Is it being sent downstream? So there's quite a bit that can be done, both from our UI as well as via things like Terraform or GitOps practices, where we have APIs and providers that we expose for management and things like that.
Nice, great. Next question here: who owns the data shipped? The concern being if some service mistakenly sends private data and logs.
So that's something that's completely kind of up to our customers. So we have certain cases where no, there's no requirement to send any raw data to the Edge Delta backend for any of the things that we've seen so far. From an account perspective, there's this concept of if we go into what are called data ingest preferences, things like, what do we actually want to send to the Edge Delta kind of UI or backend versus what do we want to just have shipped directly to streaming destinations, archive destinations. So, certain customers use Edge Delta strictly kind of like our UI or our backend, strictly from a fleet management perspective of deploying the agents, the configurations, the integrations to the downstream platforms. But then none of the underlying data is ever sent to our backend, because the actual analysis analytics is happening kind of at the point of data creation as data is flowing through those systems. So it's all kind of optional and up to the customer in terms of what data gets sent where, what you want to have streamed to Edge Delta versus sent, specifically to downstream systems that are configured there.
Awesome. And then last question here, the main focus has been Kubernetes, but can I safely assume that you can also run on Windows systems / non-containerized apps?
Yeah, absolutely. So, as I mentioned, this example is Kubernetes focused, but, absolutely. So from a deployment standpoint, if we go back to that onboarding flow that we walked through before, very simple to whether it's, Windows, anything Linux, bare metal, doesn't really matter. At kind of an agent level, we have a concept of inputs or sources. So, those are typically things like, hey, are we reading from a flat file on disk, and where are those files located? In the case of Windows, it might be what are the Windows event channels we want to analyze and bring in. So yeah, absolutely. And those are, I'd say, probably just as common as Kubernetes, but we've definitely seen, an uptick in Kubernetes deployments over the last probably year or so.
Excellent. All right, that was our last question, Zach. Is there anything else you want to cover before we hop off today?
No, I think those are all really good questions, and it's probably a lot to digest. It's Edge Delta is definitely kind of a new concept and kind of a new architecture of observability, and being able to kind of take on this challenge of data volumes, observability data, exploding exponentially. But it's yeah. So hopefully found some things interesting there, and happy for anyone who's on the line if you want to follow up further or have more questions or want to dig in. Should have our contact information, be able to reach out and dig in further.
With that, just wanted to say thank you for all in attendance. As Zach said, if you have any follow-up questions or anything of that nature, you can go to our website, edgedelta.com, and there is a contact option, or if you should have our contact information and you can reach out directly. But again, thank you for joining today. I hope you got some value out of this webinar, and we will be in touch. Thanks, everybody.
Yeah, thanks, everyone. Bye.